For decades, we've been in the era of information technology, an age shaped by data-driven systems and algorithms, refining how we turn raw data into information. But these systems have been stuck in reaction mode, analyzing the past instead of controlling the present. As the pace of the world accelerates, it's clear, systems that rely on after-the-fact insights simply can't keep up. The world is moving faster, demands are higher, and today's systems are constantly reacting to a reality that's already passed them by. We've been locked in a cycle where machines analyze what's already happened instead of taking control in real time. That's the gap we're about to close. Event computation is the key to bridging this gap. It's a fundamental shift where systems don't just store data, process it, and deliver insights after the fact, but understand and act in real time. With Decision Zone, something far more powerful has arrived. The future isn't about collecting and curating data sets. It's about using real-time events to drive instant action and autonomy. For too long, industries have relied on reactive, data-driven models where decisions lag behind the reality they're meant to shape. The DADA-X agent platform empowers organizations to move beyond traditional data analysis into a world of real-time causal control, fundamentally changing how industries operate, from autonomous systems to smart cities and beyond. We're graduating from the information age and entering the age of causal control, a new era where systems don't just process data, but control events in real time by understanding causal relationships. This era is defined by systems with the knowledge to anticipate, adapt, and act instantly, delivering precision and autonomy like never before. To grasp what this change means, it's crucial to understand the difference between data and events. Imagine standing on a busy street, watching cars go by, pedestrians hurrying along, and traffic lights changing. Those are events, the dynamic, real-time flow of occurrences that shape our world. Now picture a photograph of that bustling city street. That's data, a static snapshot of information frozen in time. Data is simply a record of what happened, stored away, waiting to be processed, queried, or analyzed. By the time data is ready for analysis, the event that created it is already over. Events, on the other hand, are dynamic occurrences. They're things that happen, real-world actions, changes, or triggers that occur at a specific moment. A sensor firing, a drone taking off, or a system receiving a command. Data can tell you what happened, while events tell you what's happening right now. But keep in mind, events happen first and data comes later. Traditional data-driven systems, by their very design, cause information to degrade as it moves further from the original event. This process is inherent in the way these systems store, aggregate, and process data. Current technology largely operates within the data-to-information paradigm, with systems designed to process information. Their job begins once the data has already been gathered, working backward to piece together meaning from what's already happened through analytics or AI-driven predictions. Enormous effort goes into optimizing how to structure, store, and retrieve data to answer complex queries. By the time these queries are run, the data is already stale and the dynamic connections that existed when the event first occurred are lost or obscured. This data-driven approach comes with significant hidden costs. Every time data is added, changed, or queried, the system requires extensive manual effort, more people, more time, and more risk. The complexity of managing static data leads to frequent delays as teams must patch, reprogram, and ensure that each change doesn't break something else down the line. As the system grows, the overhead increases. You need more specialists to manage databases and more effort to handle dependencies. Data-driven architectures are slow to adapt and costly to maintain. The result is not only a more expensive system, but a system that is constantly reactive, always trying to keep up with a backlog of issues caused by outdated data structures. What if we didn't have to wait? What if we didn't have to store and process data after the fact? What if we could compute directly on the events themselves while they're still unfolding, instead of waiting for them to turn into data? What would it mean to act in real time, to make decisions and take control as events happen, without the lag, without waiting for the event to die and become data? Imagine the possibilities if computing could be that immediate. How would that change the way we operate systems, respond to changes, and take action? But this isn't just a what if. This is exactly what DADA-X was designed to do. DADA-X agents compute directly on events in real time, giving you the ability to make decisions as events are unfolding, without waiting for them to turn into static data. It doesn't need to wait for data to accumulate or for queries to be crafted. Instead, DADA-X operates at the moment of occurrence where events unfold. DADA-X works in the present mode, performing computation on events and dynamically controlling outcomes. This isn't just a marginal improvement, it's a paradigm shift in how we approach computation and control. Here's where the transformation becomes clear. On one side, we have information technology, the world we've been living in. It's all about processing data to understand what happened in the past and then using that information to project what might happen next. Data becomes information, but only after the event is over. Event computation is different. Instead of just telling us what happened, it tells us why it's happening right now. It doesn't stop there. By understanding causal relationships, event computation gives the agent the ability to control what happens next. The shift is clear. Traditional systems are about data and information, always lagging behind. But with DADA-X and event computation, we move into a world of knowledge and agency, where systems not only understand the present, but also take action to shape the future. There is a huge difference between computing on data and computing on events. Where traditional systems start, by analyzing stored data, DADA-X has already acted, making decisions in the moment. We end where they begin, because for DADA-X, the real power lies in controlling the flow of events, not waiting for the information to be processed. Event computation transforms systems from being passive observers of data to becoming active controllers of real-time events. It eliminates the delay between observation and action, allowing decisions to be made as events happen, not after the fact. It's like upgrading from a rear-view mirror to a steering wheel. As systems evolve and the volume of data grows, traditional data-centric approaches struggle with state-space explosion. These systems require armies of IT professionals and significant computational resources just to handle the growing complexity, making them inefficient and increasingly costly to maintain. But with DADA-X's direct event computation, we capture the essence of what's happening without needing to track every possible state. Instead of getting bogged down by the explosion of possible states, DADA-X narrows the focus to the causal relationships that matter, avoiding the need to store or compute every combination of possibilities. Decades ago, the choice to use relational databases locked in a specific approach, one based on total ordering. Total ordering means that every piece of data must be related to another in a strict sequence, even if there's no real-world reason to impose that relationship. Forcing all data into a single total order creates unnecessary complexity, leading to slower performance and inefficient systems that are rigid and costly. This is where DADA-X takes a fundamentally different path. Instead of relying on total order, DADA-X uses posets, or partially ordered sets, which allows us to only define relationships where they actually exist. This means that events or data points that happen independently don't need to be forced into an arbitrary sequence. We can model causal relationships as they naturally occur, which gives us a system that's more flexible, more elegant, and far more efficient. In the world of event computation, understanding how events relate to each other is crucial. Let's discuss these two ways of organizing events, total order and partial order. On the left, we have total order. It's like a strict timeline. A always before B, B before C, and so on. Simple, but not always realistic. But real-world events are often more complex. That's where partial orders, or posets, come in. Look at the diagram on the right. Here we still have some clear relationships. A comes before both B and C, and both B and C come before D. But notice how B and C aren't connected. This means they're independent or concurrent events. They're free to happen in any order or even at the same time, just like in real life where you might check your email while having coffee. DADA-X can model both causal dependencies, like A leading to B and C, and concurrent events, like B and C happening independently. Think of traditional systems as trying to fit everything into a single straight line, forcing everything into a strict order, even when events aren't directly related. DADA-X, on the other hand, sees events as part of a network of relationships where only the relevant connections are tracked. This flexibility is why posets are so valuable. This makes it far more efficient and able to adapt in real time. In real-world applications, this could be a workflow where some tasks depend on others, but some can happen in parallel. Or in a distributed system, where some events must happen in a specific order, but others can occur simultaneously across different nodes. DADA-X uses state machine methodology that integrates processes using causal operators. By computing at the event level, DADA-X prevents isolated changes from causing unintended disruptions elsewhere. Teams no longer need to manually trace dependencies. DADA-X does it in real time, allowing for proactive control and system-wide awareness. As DADA-X works, it produces live consolidated audit trails. This ensures that each event in your system is verified for correctness and processed instantly, providing continuous feedback and control in real time. This creates a new level of visibility, accuracy, and security across millions of connected event sources, allowing for proactive decision-making. DADA-X's approach to event computation isn't just more efficient, it's more sustainable. Low computational overhead, energy efficiency, and ability to compute in real time allow DADA-X to outperform traditional systems at a fraction of the cost and resource use, operating in watts instead of gigawatts. Instead of investing in massive data infrastructure, DADA-X redefines what's possible in computing and energy efficiency, streamlining the future, not scaling yesterday's inefficiencies. We operate in a world defined by eventfulness. For too long, we've been trying to understand this dynamic world through the lens of static data. Standing on the fixed ground of data may feel comfortable, but now it's time to learn to stand while riding the waves. The future is about thinking in the flow, where systems don't just store data but actively compute on event streams. It's about causal control, where we don't just understand what happened, but know why it happened, allowing more control over what will happen next. The shift from data to events isn't optional, it's a necessity. As we move toward the era of artificial general intelligence, the limitations of today's data-centric systems becomes clear. True intelligence, one capable of adapting to the world in real time, can't rely on analyzing the past. It needs to operate in the present, understanding causal relationships, making decisions as events unfold, and controlling outcomes dynamically. This is why DADA-X causal control is so important. By understanding events and their causal patterns, DADA-X enables a new form of machine intelligence, one that thinks in real time just like we do. This is more than an advance in computing. It's a key to unlocking the next generation of intelligence, where systems don't just predict but adapt, where they don't just process but act. We're not just turning a page, we're opening a whole new book in the history of technology, one defined by real-time event computation and the rise of truly autonomous systems.